Now, we said as we continue to compound more and more and more, we see that our dollar amount actually doesn't change too much. So we actually have this problem right here, and we compounded, or we computed it 6 different ways, right? So if it's just compounded once a year, there was $962 in our account. But if it was compounded hourly, we got it all the way down to hourly, right? There'd be 8,760 compounds in a year. It gets to be 996. So you'll notice that it starts approaching this value, right? It starts approaching this same number all the time. And so what we can find out is that we actually have something called continuous compound interest, which is like when we take the limit as it gets closer and closer to compounding infinitely, right? Continuously, all the time. And as those numbers increase, as n increases, it still kind of maintains out this number, right? And so what we end up finding is that this number ends up being this equation right here. We call it the PERT equation because it's principal E, interesting, because we said, as x increases towards infinity, right, we get this E value, this Euler number, and so we can actually use that in continuous compound interest. And then we have to the RT power. Now notice there's no n, doesn't matter how many times it's compounded because it's continuous, right? Because we've already let x be up to infinity. And so we end up just getting r times t as our exponent, right? So let's look at a problem with continuous interest, right? It says, suppose Christy finds an account that actually allows her investor $300 at 6% interest rate compounding continuously. So it's just compounding all the time, all the time, all the time. So it's the same as like it's going to be compounding it every minute or every second, right? It's just continues to compound all the time. If there are no other deposits or withdrawals, how much is in her account after 20 years? So we said if it was 365 times in a year, it was that what was it? It was that 995 amount. So let's see if it's compounded all the time. Okay? So A is equal to P to the E to the RT power, PERT, right? P E to the RT power. So let's put in our numbers. So our principal is 300 again. And then we're doing E to the power of R, which again is 0.06, times our time, which again is just 20 years time in years. And so we just go to our calculator, and E is actually an option on here. If you look, it's right next to 4, and it's actually a second, and there's ln. We'll talk about what that is later. But so we go 300 E to the power of 0.06 times 20. And when I do that, I get 996.04, right? So if we were to compound this continuously, the difference between that and compounding it every day is only a difference of 10 cents, right? So that's where our E comes into play, right? So let's take that example. I want you to try our example that we just tried before, where you have $1,000 invested 8% over 10 years. How much is it if you use continuous compound interest?